Good afternoon, everybody. For those of you where that applies. I'm Brian Bockelman. I'm an investigator here at the Mortgage Institute for Research, and I want to talk about security and Condor 9.0. Now that is a approximately impossible large topic. So I'm going to narrow it down a little bit. I'm not going to talk about security in general, where we could talk about things like code analysis and threat models. I'm going to skip down and talk about how we handle authorization and identity, point at a couple of places where we've been tinkering and working, and maybe get a chance to prime the pump before today's panel, where we'll be going in a little more on some of the bigger picture changes. So this is the slide that I showed last year at Condor Week 2020, and I decided that my talk was subtitled, Forget What You Know About Condor Security, We Changed It. And I guess my message for this year is we kept working and kept on making changes throughout 2021. So a couple of things are repeated because I think they're important enough ideas that they're worth repeating. And some things I hope will be new to everyone here. I decided, particularly since I'm starting to work back from campus again, and I'm on an academic campus, that I'd have to go into professor lecturing mode for just 1 second, just 2 slides if you could bear with me. And I want to talk a little bit about how I think about Condor authorization. In the end, Condor authorization all starts with a client making connection to a server. And at the beginning, the 2 sides are a mystery to each other. The client doesn't know who the server is. It could be the person they intended, maybe, maybe not. And same with the server. So the 2 sides have a simple handshake. They agree on a list of different authentication methods to try. And as they iterate through that list, on the happy side, they are successful, they authenticate with each other, and they establish mutual identities. And especially in the Condor model, the mutual identities are important. So not only does the client have some idea who the server is, but the server has an idea of who it believes that client is. So at this point, we've now established an identity on both sides of the connection, and we can proceed. So each side is going to use that identity and do a lookup into the list of authorizations. And the input is the configuration files. So maybe it says, I allow Brian to write into the Condor schedule. And maybe Brian decides that he allows himself to talk to a particular server. So again, that authorization occurs on both sides. And once the authorizations are calculated, we actually save the resulting information into a session. So sessions will have, for example, a unique identity. They'll have an expiration time, a list of actions that the remote side is allowed to do, the actual identity that's associated with the session, and a private key that allows session resumption and perform things like encryption. The idea, once you have that session established for that remote connection, then things can happily go along their way. Brian can submit, remove jobs, I can update ads in the collector, whatever it may be that I'm permitted to do. It's based on what was written into that session. So that's the 3-minute overview of how we do authorization. That is, we establish authentication, do an access control list, and then use the resulting authorization to build a session. And going forward, what have we worked on changing? So I'm going to talk 4 ideas here today. There's, of course, a lot more that will be left unsaid, and we have the opportunity to throw tomatoes at me in the panel that's happening next after this talk. So I'm going to talk a little bit about ID tokens and side tokens, but primarily ID tokens for the new authentication methods. We're going to mention the default authentication changes, but of course, those have been hinted at a couple of times. We're going to talk about different ways that we auto-generate sessions these days. And then finally talk about a slightly different model that we're trying out for job identity. And since the title of the talk did say security, I'd be remiss to not mention that indeed we have upgraded things like encryption and integrity to modern algorithms, if the modern era at least starts 10 years ago. So I'm not going to cover too much more in this talk besides to say your security people will no longer wince when they see the Condor security configuration when it comes to crypto algorithms. All right, topic one, the ID token. And there's your beautiful base 64 encoded ID token right there, free of charge. So the ID token is indeed a token that can be used by a client to prove possession of a shared secret and show that the remote side or the client is in possession of a valid token. This helps establish an identity to the other side. And one thing that's really important here is to realize that each token that is generated is signed by a signing key. And indeed, if guys have seen previous talks, we used to refer to these signing key as password or pool password, but trying to use this new set of phrases to maybe more clearly identify what we're talking about. So the server uses the signing key to ensure that the token is valid, that wasn't just signed by the client themselves. And the way that the cryptography works, that the signing key is actually also required to be used to validate a token. And the really important consequence there is that an ID token can only be used by a client, and a server has to have a signing key in order to do the authentication. So that means that a daemon with only an ID token cannot by itself serve as a server in this authentication method. You say, aha, well, that's a problem. And indeed, I would say, aha, it's two topics from now. So we'll get to that. So in addition to an identity, each of these tokens also have issue times, unique ID for traceability, as well as potential limits on how the token's allowed to be used. For example, it might have an expiration date or authorization limits that prevents people from using them in specific cases. If you want to take the base 64 encoded token and feed it through a decoder and see what's actually inside, these are approximately what it looks like. You have the header, body, signature. And within that body, we describe all sorts of things about the user and what they're allowed to do. For example, here's the subject. This is my user identity. I get some sort of unique identifier, so I know which token this was. The issuer, when it was issued and expired. And in this case, I chose to add some authorization limits. This token, no matter what the remote site is configured, is limited to being able to read. So to let you in the big secret, there's nothing new in terms of token formats here. This, in fact, is a JWT that is fairly popular in use across several different web technologies. So an important thing that's changed with the ID tokens work is, unlike, say, with SSL, where we say we can use host certificates or X59 certificates, but go off and bother somebody else to get them. We're not going to provide you any tools. With ID tokens, we provide several different ways that we can create the tokens for users and for distribution. Perhaps the most primitive way, the caveman writing on walls way, is Condor token create. And that simply takes the signing key and puts exactly in the token whatever you tell it to. So you can give that resulting token an identity, a lifetime, multiple authorizations. But unfortunately, you can also give it bad identities. You can give it incorrectly named authorization. So it's a tool with fairly sharp edges, but it's useful for sysadmins to create tokens directly, whole cloth, no questions asked. Another way that's a little more refined is using Condor token fetch. And this is to allow users to create tokens for themselves. So for example, if I am logged into a SSH or to a SCSD through SSH, I can use Condor token fetch, get an ID token that is equal to my existing identity, and then take that token home and use it somewhere else, or go talk to another daemon in the same trust domain. So Condor token fetch prevents a lot of the misconfigurations or issues because simply the SCSD generate, or the remote daemon generates the token, not the user. And then finally, one that I'm really excited about and that we've been working on for some time is idea of Condor token request. And this allows an anonymous user to securely request a token for any identity they'd like. And of course, I can ask you for a token. I can ask you for a lot of things, but the idea is the admin will review the request and out of band decide how they want to authenticate the issuer or the user. Maybe the user called them up on the phone, maybe they check the passport of the user, and then the admin decides to approve a token and issue the identity. And this is really useful for things like being able to get token access onto my laptop without actually having to copy paste tokens back and forth, without having to use Condor token fetch. And in particular, we see this as one way in the future that we're going to be able to start bootstrapping identity across the different daemons within the system. So one gotcha with this, and why this is somewhat a work in progress still, is this whole concept of anonymous user that we can talk to securely. And in fact, in order to do that, right now we look at the different Condor authentication methods. This really applies SSL authentication, which is really tricky to set up. And this is something that we're working on in Condor 9.1. And in fact, I have some pull requests if anybody would like to talk about that later. So second topic. So I want to state and celebrate that we've been tightening down how we can do out of the box authentication. In fact, the default authentication used to be host-based. That means anybody coming from a particular IP address was trusted as if they were root at that IP address. And for the most part, that's probably not what you wanted. So for example, the collector could never tell the difference between the real SCSD process and any old user logged in via SSH. So in Condor 9.0, and this in itself might have been a reason to call it 9.0 instead of 8.10, there's no host-based authentication that is enabled by default. So there's a nice long list of authentication options that are there. And I think we will continue to ratchet it down and maybe reduce what we view as less secure options throughout the 9.1 series. So for example, one of the things that are in my crosshairs is by default for reading from Condor, so Condor, I think Condor Q, Condor status, claim to be is automatically added. And that's not really one thing that at least I'm not too proud about. So the recommendation in terms of bootstrapping is the share pool password among the trusted hosts, the way that Todd Tannenbaum showed today, and then generating ID tokens for user sessions. So we think ID tokens is going to play an increasingly large role in terms of bootstrapping and authentication within your cluster. And this, in fact, is what the current install script get HTCondor does for you. And then finally, encryption and integrity checking occur by default. They use a modern algorithm, and integrity checking now also covers file transfers. So if you transfer your gigabyte file, we will detect if there was a bit error on the network. Next topic, how are different ways we're using sessions? So for many years, Condor's had the idea of match password security, which have nothing to do necessarily with passwords and only marginally things to do with matches. The idea is the start D would generate a session, create a token representing that session, and send it along to the collector. The idea that token would create a known authentication, and anybody that the collector trusts with the token, such as the negotiator or the SCED, the worker node would trust to start jobs. So that way we had these two trust relationships, all based on this central collector. And because the start D trusts any negotiator, and the negotiator trusts any SCED in the collector, the start D can therefore trust any SCED in its collector. And the idea here is that we continue to bootstrap up from trust within the collector and have that be our central point that we all trust and can do transitive trust between each other. Then. So that session, again, is serialized, sent to the SCED, and that's sent as part of the match. And that's why we ended up with the somewhat creative name of match password. That's been around for many years, but throughout 8.9, we've been, and now 9.0, we've been working in different ways that we can use that collector as a central point of trust to bootstrap trust through the rest of the ecosystem. So last year, we had made it so that the negotiator used transitive trust to talk to the SCED. The SCED and negotiator no longer had to have a mutual trust relationship, but instead this could happen by pre-generated sessions. In the last year, we've also been working on user level flocking, which allows, instead of the SCED level to be trusted by the collector, an individual user to be allowed to be trusted by a remote collector. And that allows a user to be able to utilize their ID token to flock only their particular jobs to a remote pool, instead of having that flocking relationship be at the daemon level. And then finally, this is a bit of a work in progress, but if you know where to flip the switch, this is present in 9.0. There's some thinking about how we use identities. And I love the example of a job because as far as I can count, there's at least 4 identities that the job has. The job has the Condor identity of the client who submitted the job. So that's what's written into my ID token, for example. There's the Unix identity on the submit host where the input files are saved. So when I do transfer in my sandbox, when I launch a shadow and the shadow acts on behalf of me, there's some Unix username that the shadow operates under and the files are saved as. There's the accounting identity. So that's whose fair share gets themed when I run 1 million job hours. And then finally, there's the Unix identity on the execution host where the job is run. So historically in Condor, this item number 2, the Unix identity on the submit host, was very much the primary identity. Everything got mapped to Unix accounts, and then there lots of decisions were made based on those Unix accounts. And this starts to have problems, particularly if you start to use clever things with the domain names and the Condor identity. So for example, if you had bbockelman@gmail.com and bbockelman@cern.ch, when it came to time generating a Unix identity, everything was truncated before the @ sign. And these two individuals, even if they were logically somebody different, would end up using the same Unix account.
Sorry, Brian, you have 2 minutes left.
Yep, we're doing well then. So, and 9.0, we can now make the Condor identity the primary identity of the job. So that means the user with the same username but different domain will not be able to manage each other's jobs. And the Unix account really just becomes the implementation detail. In fact, in 9.0, we can set things up so the Unix account doesn't even need to exist on the SCED, and that the Unix account can be mapped to the username nobody. And this allows, for example, people using web portals to submit under the user's actual identity, but then not have to bother with provisioning a Unix account in order for it to run jobs. There's a couple pieces of work left, especially around isolating jobs from each other on the SCED. So this is available or defaults off and configured behind a hidden variable. But this is one thing I'm hoping to further expand and work on in 9.1 or 9.1. So a few things that are to wrap up. First of all, ID tokens provides a pretty simple and effective mechanism for securing Condor pool. And more importantly, we're starting to provide tools to help admins actually bootstrap and get the ID token work going. Because of this, we're able to move forward and disable host-based auth by default and enable encryption and integrity by default. And there's some things left to do in 9.1. So right now, there's still a pretty big hassle around the distribution of signing keys. As Todd did in his demo, you have to actually know and manually put in the password yourself. I think there's a lot of things that we could do in terms of trust on first use and taking inspiration from SSH. And then also there's some cleanup work left to do on ID tokens to make sure that even if a daemon only has ID tokens, that we can still do the normal administrative commands, Condor on, Condor off, fetch log or defrag, even though it doesn't have the signing key. So those are big projects that we have looking forward, and we're looking forward to seeing what we'll talk about next year at Condor Week. Thanks.